Welcome back. This will be examples 1 and 2 for chapter 11, section 1. So let's just switch and get into them. Sorry, for some reason my hover cam is not zooming in, so you're going to have to bear with me as we do this. But the first one is pretty straightforward. We're just finding mean, median, mode, and then measure which measure of center best represents the data. So as I explain this, I'm going to kind of explain a lot here. But to find the mean, median, mode of these numbers, okay? I'm actually going to click back to our notes because it's just pretty clean there. We can see them pretty easily. So let me get this off the screen. And let's click to example 1. I'm going to choose to go through the click-through example. So as we look through this, to find the mean, median, and mode, the mean, remember, we're just going to add up all the numbers and then divide by how many numbers. So there's 1, 2, 3, 4, 5, 6, 7. We got 8 numbers. Add them all up, divide by 8. You find the mean is 9.65. So if this is students' hourly wages, one way to represent how much all the kids made is 965. Now, when we want to look at the median, if you're going to find the median, this is a little bit more difficult. So let's switch back to our camera. If I'm going to find the median of all of these numbers, it's not really easy to find the middle number right off the bat. So what I really want to do is I'm going to list them from least to greatest. Or if you remember how we've talked about it before, ascending order. So you want to be meticulous about this. You need to mark them off as you go through. So the lowest number, 825, 8.25. After that, we have another 825. After that, we have an 845. Please be filling in your notes with me if you're watching. 865, 875, 910, 925, and 1650. So let me zoom out a little bit so you can see my numbers. Again, sorry for the camera. Now, there's 2 ways you can go about doing this. You can just tick off from bottom to top, and you can start seeing which one will be in the middle. This works when you only have a couple numbers, and that's fine. If you're only using a couple numbers, this will work. I apologize, that marker is a new marker, so it's not working great. Now, since I have 2 numbers in the middle, I don't have a single mean, so I have to actually compare those 2 and find the middle number between them, or since I don't have a median, I need to add those 2 up and divide by 2. So it's 8.65 or 865 plus 8.75. Most of you guys are probably able to do this in your head and just say what's right in the middle. And you'll see that it's 870. So right now my median is 870. Okay. So the median is just the middle number. That's pretty easy to see. And as we go back on our notes, we click through, you can see here our median is the middle of those 2, 870. Okay. Now, when we look, we want to say, okay, how do I find my mode? My mode is the number that occurs most often. And when you have them already listed like this is a lot easier. So when I'm going to click through and go to our mode, well, when I look, these 2 occur the most often. So my mode will be 825. Now, which one was the best at these? Well, let's look at all 3 of our answers. We had a mean. Let me erase up here, please. I should have kept those numbers up there. This is the default. This is the problem of not having a nice big whiteboard like we have at school. But my mean was 965. My median was 870. My mode was 825. Now, when you look at these, Let's look at this for a second. A mean of 965. Does it really make sense? And let's look at all these numbers here. It's easier, actually. Let's look at them right here because these are in order. Does 965 really represent how much everyone made? 965 is more than everyone made except for one person. I would not say 965 is a good representation of this set. Okay. Now, let's ask a deep question right now. Why is that a bad idea to use this as a representation? I think everyone right now can look at this and say, no one make that much except for this person. That leads us into one of your definitions of an outlier. What an outlier is a number that doesn't really represent the set. Or it's a number that is so different than all the other numbers, it sits outside. So when you look up here, all these numbers are pretty close, except 1650. 1650 is way out there. That's an outlier. And what it does, the way we speak about it is, it pulls the data one way. What it does is it makes the mean seem way higher than it should be. So whenever you have an outlier, you will not use the mean as the best measure of center. So when we are trying to measure our center, it's going to go in this order. You'll go mean, median, and then mode. You use the mean unless you have an outlier. And then 99.999% of the time, you'll use the median over the mode. You'll only use the mode if like more than 50% of the data is the same. And truthfully, statistically, I've never really seen that come up in the real world. You could see some theoretical models come up, but you're just not going to see that in the real world very often. And this is when I miss some of my kids in class because I know I'd have 5 people shouting at me, oh, but this, but that. But sometimes it does. Now, I am going to go onto Desmos and show you how to find these things right now. So if you look on your notes, you have a little Desmos command center. That's where we're going to be looking here. So now you can go into Desmos and remember how to add sets here. So we're going to go to add item. This is where you're going to add your table. We're only going to use the X1 column because we're going to be using, this is single variable statistics. We're going to sound really smart here for a second, but single variable statistics just means we're talking about one thing. That's it. Bunch of big words to make it sound smart, but it's really not that complicated. And I apologize. I should have had this. I do have it written down. So now I'm going to type these in. So the first number was 1650. Then down 875. Down 865. 910. 8.25. 8.45. 8.25, 9.25. Okay, so now we have our student hourly wages in the set. Remember, this is under X1. That number is important. So now I'm going to come down here and define all of the stuff for this. Let me go to this section. You go into your keyboard, go into functions. And right now we are finding statistics. We will be looking under statistics. So we go under stats. And you can see a couple of things right here. Right off the bat, we have the mean function. So you go mean X1, and it's 9.65, as we found before. Please do this by hand. This is not arithmetic that you should need to use this for. If you have over 15 data points, then that's fine. Go ahead and use it. But if not, please get used to doing this by hand. We all can use the math practice. The median is 8.7, which we found. Okay, so you can find the mean and the median. if you look, I don't believe they have something for the mode because that should be pretty obvious. It's just the one that occurs the most often. So now, not only do you know how to find mean, median, and mode by hand, you know how to find them by Desmos as well. So now, example 2. We already talked about this, but when we look at example 2, they simply asked us, identify the outlier. How does the outlier affect the mean, median, and mode? So if I want to know how the outlier affects the mean, median, and mode, I want to take it out. So what that means is I'm going to remove the outlier from our data set. So it'd be like I just went like this to our data set. We can look at all these numbers. Which one's not like the others? 1650. So I'm going to take that out and then put it back and then go back to my data set and redo everything just like before. So now let's do that. Excuse me, I need to figure out how to. There we go. So now we have to go into example 2. Sorry about that. Monitoring progress you can do on your own, but we're going to go to the click-through example in example 2. So now for example 2, the value 1650 is way off, so that was our outlier. We talked about that extensively. The mean, notice how they just took the outlier out, and remember this number goes down by 1 also. So now we see that our mean has changed. Our mean has changed drastically. It was 965, now it's only 867. The median and the mode. The mode didn't change at all. The median changed a little bit. So when you look at this, when you remove the outlier, the mean decreases. And that makes sense because remember how he described it? This pulled the data set up. It made it seem like everyone made more money because we included him in our mean. But now that he's out, we get a much better representation of the data. The mode was exactly the same. The median decreased a little bit, but it only decreased by 1 down because we didn't have to average it. So now they just asked, what could it represent? Anything would be acceptable here, realistically. You could say this could be a manager. This is someone who worked, or like this, they said it was just a different job. Okay. Anything's really acceptable here. What I'm really more worried is you understand what it does. And that concludes examples 1 and 2. On the next section, I will go over examples 3.